Have you ever wondered how your phone recognizes your face in an instant? Or how your email knows which messages belong in the spam folder? It feels like magic, but these systems rely on a basic machine learning concept called logistic regression. The name can be a bit confusing. While regression usually involves calculating exact numbers or values, this specific method focuses on making clear, definitive choices between categories. It looks at data and answers a simple yes or no question: true or false, spam or not spam, disease or no disease. Whenever an app needs to choose between two options, logistic regression is usually the invisible logic engine doing the work. To understand how this works, think about what happens when you look up and see heavy, dark clouds. You intuitively know there is a high chance of rain. Computers arrive at these answers by analyzing past patterns to calculate the exact probability, the chance, of an outcome happening. Let's look at a classic example: predicting whether a student will pass or fail a test based on how many hours they studied. This chart shows past student records. The system notices low study hours usually result in a fail, while higher study hours result in a pass. But analyzing this pattern, it predicts a student studying 5 hours has an 85% chance of passing. So, at its core, logistic regression is a probability calculator, measuring certainty. But there is a catch. Probabilities have strict limits. You can't have a negative 30% chance of passing, or a 120% chance. The math has to stay neatly between 0 and 1. To keep the math within these boundaries, the system uses a special S-shaped curve to squeeze any input number into a safe probability. This graph shows the result, a specific curve that stays carefully bound between 0 and 1. Notice how the line behaves. It stays flat and low at the bottom, rises sharply through the middle, and then levels off completely at the top. This maps perfectly to our students. Studying for 1 hour yields a very low chance of passing. 3 hours puts you on that uncertain, steep middle slope, and by 5 hours, the chance of passing flattens out near the very top. This curve captures how things work in the real world, where outcomes often build up gradually before suddenly becoming nearly certain. Now we have our 85% probability. But how does the system turn that percentage into a definitive pass category? It does this by using a firm cutoff line, known as the decision boundary. Most systems use a simple 50. The decision boundary is what forces that mathematical probability into a strict, actionable category that we can actually use. To really lock in how this works, let's contrast it with another popular method: linear regression. Linear regression asks the question, how much? It predicts exact numbers, like what a house might cost next year or a starting salary. Logistic regression asks which category. It predicts choices, like whether a specific bank transaction is fraud or perfectly safe. Think of it like a seedling. Linear regression asks, how tall will this plant grow? The answer is a number, like 18 centimeters. Logistic regression asks a yes or no question. Will the plant survive? The answer is a category based on probability. Linear estimates scale and quantity. Logistic estimates survival, success, and definitive categories. In short, logistic regression is the machine learning method that predicts the probability of yes or no outcomes using patterns from past data. It is the silent judge running inside banking fraud detection, hospital diagnostic tools, and the media algorithms deciding what you see next. If you want to explore the data behind these models, we've linked some learning materials down in the comments. Be sure to follow and subscribe for more deep dives. Ultimately, even the most complex AI systems rely on these fundamental building blocks, turning patterns into probabilities to help us make better decisions.